zinc thermal spray can be used on the hulls and superstructure of vessels such as trawlers. And later on, we'll see an example of zinc thermal spray as it's used on wind farms. So the purpose of this seminar is to engage with architects, engineers, and other specifiers about the benefits of using hot-dip galvanized steel on a myriad of projects. And we've produced a marvelous booklet for you with everything you'll need about galvanizing. Just to briefly introduce you to the concepts of zinc as a material for galvanizing, it offers three possibilities. Firstly, it's a barrier. Secondly, electrically, it is the cathodic protector, and it is actually sacrificed first. And thirdly, it forms what we call a zinc patina, where it reacts with the atmosphere with carbon dioxide to form a very tough film. But that I'm going to leave to the experts later, to Terry Smith, who'll come in a short while. But finally, for those of you who are architects and designers, look what you can do with hot-dip galvanizing. This is a facility in Santa Barbara in California, both office and residence. Look at the contrast, the beauty of color, and look at the contrast where there is hot-dip galvanized steel used in the structure. So not only is it beautiful, but it's extremely useful. And with that, Shannon, it's back to you.
Thank you very much, Simon, for that informative introduction on the use of zinc in galvanizing. Let's move now on to our second guest, Mr. John Matthews, President of Master Builders South Africa. John currently holds the position of Group CEO of the Garden Cities Group of Companies. He is also the chairman of the COVID-19 Construction Rapid Response Task Team. John completed an MBA at UCT in 1997, specializing in strategic management. His areas of interest include the provision of housing and other social services to uplift the people of South Africa in a sustainable manner. John is going to provide a brief overview of the current state of construction in South Africa and highlight the many opportunities open to this industry over the coming years. Thanks, John.
Thank you very much. Thank you very much, Shannon, and thank you for the opportunity. I certainly now know what zinc is all about. I never knew all the properties of zinc. Yes, I'm going to try and provide you with a very brief overview of the current state of our construction industry. And I must say it's going to be very brief because we know that we've certainly been in dire straits prior to the COVID pandemic that we've had. I think we're all fully aware of the situation at the moment, that we are in what's called a full-blown recession. According to Inside industry numbers, the economy has contracted by some 2%. And these numbers I'm quoting you have to bear in mind is prior to COVID, because this is for the first quarter of this year. SA stats have confirmed that these stats are prior to the COVID-19. A significant feature of the economic pullback is that the gross fixed capital investment was 20.5% lower in the first quarter. This means that any fixed capital investment has been 20% lower than the previous quarter, and that is very, very worrying, because that means that there is no investing into our economy. What concerns me more is that there are certainly going to be a lot more in terms of our numbers, and a lot more negative numbers that we're going to see going forward when we come up with the second quarter of this year and understand what the impact of COVID has had on the whole economy, including the construction industry. However, with these challenges come opportunities. And I think there are opportunities, and we have to take those opportunities seriously, otherwise we will be in trouble even further than what we are. I also think that the government needs to play their part, and this is where we really need to show, from a private sector as well as a public sector, need to show leadership and real leadership. The time for talking is long gone, and I think we need to start walking the walk in terms of the economy. Now's the time to create employment. we can set aside as much money as we want to for social grants. That's not going to kickstart the economy. I accept that there is a need for grants, but unless we start unlocking those big projects that everybody's been talking about, and we hear from our president and all our ministers that these projects are in the pipeline and we have infrastructure spending coming, unless we actually start doing that, we're actually going to be stuck in a situation where there is no value added, because we know for a fact there's no value adding within social grants. It's needed, but it needs to be balanced with real investment on the other hand. In total, 26.8 billion rand have been suspended in investments through various government organizations in order to provide for COVID-19 requirements. However, of the 26.8 billion, only 16 billion has been reprioritized. And I asked the question, what has happened to the other 10 billion rand? Because if it's not being spent, then it is stuck somewhere in a system where it should be spent on infrastructure investment so that it can kickstart employment and create, so that it can kickstart the economy and create employment, and we can get the cycle of the economy reversing again rather than going backwards at the moment. The Rapid Response Task Team has engaged with government on various levels, and we've had some success with regards to opening the industry. And it's almost a forgotten issue now that when we were in level 4, we were all vying for the idea. In fact, when we were in lockdown, we were all vying for the idea to get us going in level 3. It happened with a limited success. And then when we started out at level 3, the entire construction industry opened. However, we haven't had the opportunity where new contracts have started within the economy. So existing contractors like myself and many, many others are sitting, trying to concentrate on doing what was left behind when we had 3 days to shut the economy, but there was no new work, and still till to date, there is no new work being allocated, because as we know, the biggest challenge at the moment is either the building plans department has closed or some other department has closed in the country. The deeds office opens for 2 days and it closes for 2 weeks. The city of Cape Town has been closed because we can't process plans. And the entire system, the entire economy has come to a gridlock, which is a huge challenge. So everybody is saying, yes, the industry is open, the economy is open, but we are not seeing an unlocking of the economy, and we are not seeing money flowing, and we are not seeing the creation of employment, which is a challenge. The promise of a plan does not put food on the table, and we can no longer wait, as we all become frustrating. And we know what happens with frustration. We've seen it in the taxi industry, and instead of the dog wagging the tail's wagging the dog at the moment. That's a topic for another conversation. I think with regard to cost savings in the industry and moving forward in terms of a micro level environment, I think everyone should have a hard look at how things are built these days. We've become too complacent with quick fixes and then ignoring the longer term effects of standard methodologies that we sometimes have blinkers on when we talk about alternate building technologies. We keep on doing, and the engineers in this forum will know about what I'm talking about when we talk about the officials referring to the little blue book. The little blue book, I'm afraid, is obsolete. We have to start thinking of ABTs and start thinking of new innovative ideas of how to create sustainable building materials, use them, and also actually to our advantage, in terms of long-term advantage, it's advantageous for our clients and for everybody that uses them. The problem that we sit with at the moment is that everybody wants to fix your roof very quickly. Everybody wants to replace something very quickly at the cheapest cost possible, and not taking into account the long-term cost and maintenance of something, rather than saying, let me invest into a long-term product or a long-term commodity, and then I will, in the long term, achieve better results. And in actual fact, it will cost a lot less. In conclusion, the building industry will not survive if the assistance and the provision of infrastructure is not forthcoming. At the moment, timing is everything to everybody. The mere fact that a restaurant is open doesn't imply that a restaurant makes money. The mere fact that the restaurant cannot serve alcohol, and there are reasons for that, admittedly, but because it's open doesn't mean it's generating income. Because the construction industry is open, or because your factory is open, doesn't mean that you're making money. We have to start understanding, and there I say we, the private sector as well as the public sector, have to understand that to unlock the economy, to create jobs, you need to have money, and you need to spend the money. It serves no purpose if the government has made promises in 2018 that they have committed to create a fund of 100 billion rand over 10 years. And according to RMB, this fund, I said 2018 if you recall that, according to the RMBT, this fund was to be administered by the DBSA, and the head of this fund was appointed in May 2020. It took 2 years for the government to appoint somebody to run the fund. It will take another 2 years to appoint somebody to actually write a check. That is a problem. We have a huge problem. The time bomb is ticking, and all we do at the moment is we're talking. So the responsibility of the RRT in the medium to long term is that we will continue to lobby, and we will continue to promote and to pressurize the government to turn the talking into walking, and to start allocating that money so that we can unlock the economy and everybody can then partake in the fruits thereof. Thank you very much.
Thank you very much, John. While there are several challenges facing this industry, it is a relief to know that it's not necessarily all doom and gloom, with several opportunities available in the sector, specifically for sustainable building materials. And I think it will probably be the brave few who will take advantage of that. Let's take a moment now to hear from our audience. We have a poll that I'm going to launch, and I would just like to find out who might be interested in a course on galvanizing and corrosion. I'm going to allow our panelists to also vote. I'll just give you a few seconds just to have a look at that. Seems we do have quite a lot of interest in a course on galvanizing. I will just give you a couple more seconds. I will end my poll now. Let's see quickly. Let me share the results with you. It would seem that 97% of you would actually be interested in a course on galvanizing. So we'll keep that in mind, and we will give all the information out at a later stage after this webinar. We are moving along now, and I am very pleased to have with us our South Africa's leading expert on galvanizing, Mr. Terry Smith, who currently consults to civil engineering on galvanizing together with Simon Norton of the IZA. Terry is going to take us through the process from design until you're ready to appoint a galvanizer. He will discuss applications, specifications, steel quality, critical design issues, and how to get ready to galvanize. Over to you, Terry.
Hi, Shannon, can you see this? Can you see my presentation?
Not yet, if you could just share your screen.
Okay.
There we go. Thank you.
Ladies and gentlemen, I'm going to talk a little bit about hot-dip galvanizing, as you heard. We asked the question, what is hot-dip galvanizing? Hot-dip galvanizing, if you take steel, hot-dip galvanizing happens when you take pre-clean steel and dip it in a bath at 450 degrees C. Zinc melts at about 419 degrees C. When the temperature of the steel reaches 450 degrees C, a reaction takes place, giving you abrasion-resistant, cost-effective coating, which will span at least 50 years in the atmosphere. Why hot-dip galvanized? Unless steel is protected, it will corrode and it will slowly return to its natural state. Putting a barrier coat on, such as galvanizing or paint, is good for corrosion protection. Unlike paint, zinc and its alloys from hot-dip galvanizing are metallurgically bonded to the barrier coat and have been around since 185 years. That's the typical micrograph of the coating. You can see the various iron zinc alloys, the steel base being 159, and the iron zinc alloys above, the gamma, delta, and the zeta layer, you can see are harder than the steel itself. So it gives you tremendous abrasion resistance. It's normally overcoated with a pure zinc layer on the outside called the eta layer. Zinc is also cathodic to steel. So at a scratch of up to 3 millimeters, the surrounding zinc will preferentially corrode in favor of the steel. This can be seen. Here's the typical corrosion cell. On the one side, we see steel, which is the cathode. On the other side, zinc, which is the anode, placed in electrolyte, electrical connection, and those four things constitute the corrosion cell. So we use this technique, the zinc sacrifices itself in preference to the steel. Corrosion creep is also impossible with hot-dip galvanizing. Here's some mechanical damage coating after 7 years in a gold mine on some shaft guides, and you can see there's no corrosion creep at all. Why hot-dip galvanized? Inspection is easy. All we have to look at is coating continuity and coating thickness. The process is extremely quick, and there's no curing time. Once it's cooled, components can be inspected and loaded on a truck. It's also an honest coating. If steel is not clean, it will not hot-dip galvanize. And here you can see typical examples. So weld slag, which is not removed, is shown typically after galvanizing. There's some oil-based lettering, which wasn't removed. You can see it. So the converse of that, if the steel looks good, it is good. And edges are also well protected, very different to paint, where paint thins out and would normally have to be stripe coated. Galvanizing forms equal coating around the edges. Comparing types of hot-dip galvanizing, you have continuous hot-dip galvanized sheet to that standard. This is the process. Items are decoiled and go through a welding process, looping, and then into annealing furnace, which is heated to about 900 degrees C, runs down into the zinc bath through these at about 100 to 140 meters a minute, through these gas or air knives, which mechanically wipe the coating to the different coating grades that are available. General or centrifuge galvanizing are both done to SANS 121. So this is the process. It starts off with jigging, degreasing, rinse, water rinsing, acid pickling, rinsing again, final fluxing, drying, and then into the zinc bath where the reaction takes place. Centrifuge galvanizing goes through the bottom process here. After galvanizing in baskets, it goes on to a centrifuge, and that rapidly spins and quickly breaks. Here you can see hot-dip galvanizing coming out of the bath, general galvanizing, and here's a spin galvanizing operation where the basket is opened out and the items then fallen out into the quench bath. Just bear in mind that the life of a metallic zinc coating is proportional to its thickness. So the thicker the coating, the longer it will last. Here's a comparison between two different specifications, one general and one continuous. Both are known as hot-dip galvanized coatings. What I've done is I've just taken the incidence of SANS 121, which is the general galvanizing spec, and I've taken a profile of 3 millimeters or less than 6. You can see the local coating thickness is 55 and the mean is 70 microns. If you look over this side under the continuous galvanized, I've got Z275, which is a nominal coating of about 20 microns and a minimum of 13.5. compare those things in a site. Here's a site at Capricorn Park, which is about 400 meters away from the high level mark at False Bay, which is a very aggressive condition. Here you can see some trusses, which are hot-dip galvanized to SANS 121, coating thickness around about 161 microns. All the purlins were only continuous galvanized Z275, get to a coating of about 5.5 microns, in some areas got red rust. And that's 3 years in a C5 marine atmosphere. This is the typical table that's given out in these three standards. You're looking at from C1 to C5 or CX environments. The more aggressive is obviously C5. If you look at C3, for instance, the corrosion rate of zinc is about 0.5 to about 2 microns a year. And you go down to C5, you're looking at 4 to 8 microns a year. And a Z275 would last between 3 to 5 years. And hot-dip galvanizing 70 microns would last between 9 and 18 years. Okay, so we have the major coating thickness appearance on influences. Not controlled by the galvanizer, has a big effect, is the steel composition, steel thickness, and surface roughness. What is controlled by the galvanizer? The zinc temperature, the immersion time, the withdrawal rate, the angle of immersion, and the alloy that's added to the molten zinc. So we look at the biggest influence. Silicon and aluminium are used as deoxidizing agents. So as you're making steel, the molten steel has to be deoxidized, otherwise it will create slivers and laminations in the steel. So they use silicon and aluminium. Aluminium doesn't really have a problem, but silicon in various levels can create major influence on coating thickness. Here we have the Sandlin curve, and to the right here you can see this is the Sandlin curve. On the y-y axis is increasing coating thickness. On the x-axis between 0 and 0.5% silicon. Where the silicon is between 0.15 and 0.25, this is really where we want it, which is a nice thick coating without being excessively thick. But you can see at about 0.08% at 450 degrees C what the reaction would be like. So high phosphorus in steel will also result in localized delamination. Now, phosphorus is not added to any molten steel. It depends on where the steel or the iron is mined in the country or in the world. So yeah, you can see this is a mast. The bottom flange is got a high phosphorus. You can see the delamination, whereas the mast itself, the galvanizing is 100%. So ideal steel, silicon between 0.15% and 0.25%, and phosphorus less than 0.02%. Preparing to go to the galvanizer, design, good fabrication, and communication is extremely important. Ensure that the design and fabrication is done in compliance with SANS 14713 Part 2 or the design wall chart. Hot-dip galvanized to SANS 121. Don't just say hot-dip galvanized at all. Discuss the finish requirements with a reputable galvanizer. Keep on communicating either way. If in doubt, get 2 samples fabricated and galvanized to the acceptable standard. And if components are too large, consider modular sizes. Employ a qualified third-party inspector for both before and after hot-dip galvanizing. Don't forget the primary reason for hot-dip galvanizing is for corrosion protection. And here we have a wall chart, which is available from the Hot-Dip Galvanizers Association. I'm sure they'd be glad to send you one of these. It contains everything that you require from a designing perspective and a fabrication perspective, and it will be a very useful tool for you. Thank you, Shannon.
Thanks very much, Terry. Just a reminder to our audience that the Q&A function is enabled, so please be sure to send us any questions that you'd like our panelists to answer at the end of the presentation. I see we have some 67 participants at the moment, so we're looking forward to getting those questions in from you. On that note, let's gain some insight on when you specify hot-dip galvanizing on your projects. I'm going to launch our second poll. Let me just, here we go. I'm going to launch this now. I'll give you a few moments to have a look at that. You can give us some more information on on how often you specify hot-dip galvanized steel, and when you do, on which projects. You can just have a look at that now. We'll just give you some time to look at that. I also just want to remind you, thank you very much for the people who are raising their hands. We are taking note of those. If you do have any specific questions, please be sure to put them in the Q&A. And just a note, if we don't manage to get a specific answer back to you at the end, we will be in touch with you afterwards. And of course, we will also give you all the contact details of all our panelists so that you can converse with them afterwards as well. I know this poll is quite long, so I'll just give you a few more minutes to do, or a few more seconds to do this one. Had a couple of answers now. I'll just give it a few more seconds. Right, I'm not going to take up any more time with the poll, but I'm just going to end this now. We've had about a third of the people voting or polling here. So I'm just going to end this now. These things are always tricky. You never really know when the right time is. So I'm going to end it now, but let's see the results. It would seem that quite a few people do specify hot-dipped galvanized steel. I think Simon will be very happy to hear that, as well as Terry. And let's go down to the bottom here. It seems most of you use chromadeck. I'm sure Simon will be able to tell us more about that later. Okay, thank you so much for voting in that poll. I'm going to stop that now and let's carry on. It seems that, as I said, you are very interested in the benefits of galvanizing. So on that note, we're going to now hear from Mr. Robin Clark, who is the Executive Director of the Hotdip Galvanizing Association of Southern Africa. He's going to explain how galvanizers in South Africa can assist engineers and specifiers with their projects. Welcome, Robin.
Thank you, Shannon.
No problem. You do have, are you going to share a slide with us, or do you want me to take over from that?
Shannon, I'm going to need your help in terms of putting up the slides.
No problem.
I'm sharing my way through some of the answers to the questions that you're going to ask. Do you want to do it in a question and answer format, or should I just roll with the notes that are prepared in answer to those questions?
I think if you're happy to go ahead with your questions as you have them, otherwise I can just start it off while I just get your share screen ready.
Okay, I'll prompt you when I need the slide up then, if that's all right. So
no problem.
The Hotdip Galvanizing Association views approximately 27 batch type galvanizers across South Africa, capable and geared up towards servicing the steel industry. By this I mean that these are plants with both systems and management commitments to deliver hot-dip galvanizing items compliant to SANS 121 or ISO 1461 standards. The association itself has 20 directly contributing members, and we assist them with marketing, training, inclusive of the CPD levels, and customer liaison and technical development. If we can put up the first slide, please, Shannon, we can maybe see where they all are. So what we have is we have approximate capability inland of doing about 24,000 tons per month of steel. The KZN region is in the order of about 7,300 tons per month of steel, and the Cape region, stretching from East London down to Cape Town itself, approximately 5,450 tons of steel. The big issue there is there are two elements that we need to understand. That is that kettle size and heating capacity are the two prime drivers for the ability of the galvanizer to process tons of steel per hour. And my calculations for these numbers were based on our members' capacity only. I'll discuss the others in a second. And this was estimated tonnage per hour times a single shift operation with an OEE of approximately 65%. We estimate in Gauteng, other plants may well be able to add another 2,000 tons per month. And in Cape Town, or the Western Cape specifically, there's probably a capacity for an additional 1,200 tons per month, 200 tons a month. In terms of bath size, and Terry alluded to it, I think, when he said the bath size, when you're designing, you would have to design to get either the steel sections or certainly the fabrications into a bath. And in Gauteng, we have 10 kettles longer than 6 meters, 5 of which are over 12 meters, and the longest of which is 15.5 meters. So well positioned to handle very large fabricated components. In KZN, we have 3 kettles, which are longer than 9 meters, and the longest of which is 14 meters. On the Cape Belt, there are 4 kettles with a length in excess of 6 meters, and 2 are over 12-meter lengths. The longest of which is 14 meters. So there's plenty of capacity available in South Africa at this point in time. And it was John that was painting a picture of our need to unlock big projects. The capacity is there, and the capability of all the galvanizers in South Africa is there to service the steel industry and get some tonnage really well processed. I was also asked the question when given the opportunity to address the audience or to address the team about passivation, and in particular the relationship between passivation and duplexing. And Terry raised the point about communication. So all galvanizers at the end of their process, they quench the steel article as it's come out the kettle. Now, typically that quench tank will be dosed with a passivation medium, fairly low concentration, about 1%. Okay. And the reason for this passivation is to normalize reactions between zinc and the environment during the progression of the zinc to a desirable zinc carbonate patterner. If the fabricator wishes to duplex the articles, this good communication really comes into play, and a note is required to the galvanizer to omit the passivation, since some paints react very, very poorly with the passivation compounds. It is therefore necessary to arrange that the newly galvanized material is transported and processed at a painter or at the galvanizer if he has the painting option before the formation or the reformation of any zinc oxides and hydroxides. So passivation is de rigueur normally, but if you want to duplex and you have a well set up logistics arrangement with a painter, it is possible to ask the galvanizer to omit the passivation step in the process. We've also asked some questions with regard to duplex and duplex coatings. And I don't know if we can put up the next slide, please, Shannon. So I am aware of 2 galvanizers that have made a direct investment in a paint application on an industrial scale. But most galvanizers have developed a relationship with paint applicators. And to expand on this, generally the project flow is the designer signs a contract with the contractor. The contractor engages with the fabricator, and the fabricator approaches the galvanizer either to galvanize or potentially to duplex. Between the fabricator and the galvanizer, they will engage with a painter, and the fabricator will be able to access a finished product, both galvanized and painted. I've taken the liberty also to expand on the question a little bit, and most of the galvanizers that we have relationships with will be able to provide a duplex system, either in-house or through, as I say, with strategic partners. Okay, most galvanizers also shot blast. They will be able to apply zinc thermal spraying to varying degrees, either as a renovation medium or possibly on a commercial basis. I believe Simon will be dealing with that in a bit. One or two galvanizers have steel cutting and profile services, and one or two even have some design services and the ability to do small fabrications in support of big projects. The other question that we were asked to address was delivery and logistics. And Shannon, if you can put up the next slide, please. So the operating norm is for a fabricator to transport and to manage the logistics for medium and large projects. In other words, bring the material to the galvanizer and then collect it. But notwithstanding this, almost all the galvanizing South Africans, certainly amongst our members, provide a collection and delivery service, either using their own resources or contracting in as required. Several of the larger galvanizers, particularly in the Gauteng area, have established an advanced logistical capability and are able to assist customers with direct transport to site fairly far afield as well. So those facilities do exist, or those services do exist. Thank you, Shannon. That's I think that's me done.
Thanks so much, Robin. That's some very important information that you shared with us. If anyone would like to be in touch with any of the galvanizers in South Africa, please leave your details in the Q&A and Robin can respond to you after the session. We'll also be sharing all the information that you might need after the webinar is over. We move back now to Terry Smith, who's going to explain the process to follow after galvanizing.
Not working.
We can hear you, Terry.
Okay, sorry. Both sizes, as Robin talked about, vary across South Africa. For large components, the undersides bars that are located close to you, you can use the modular principle. Athlone Stadium arches is a good example of this. There you can see the actual view on the Athlone Stadium arch, spanning about 192 meters, and in cross-section size around about 6.5 by 6.5 meters, almost impossible to galvanize as a single component. So all the tubes were processed, so they were prepared for hot-dip galvanizing by masking the ends, and for welding purposes. They were galvanized on jigs, which gave them the right angle, right immersion. And then afterwards, the mask was cleaned off. The items were welded. As you can see there, they're uncoated areas. And then that was zinc metal sprayed, and that arch got 2 coats of paint. Acceptance and inspection. If the component was designed and fabricated correctly, the coating thickness and appearance is the only things that are necessary. Ideally, at this inspection should take place at the galvanizing plant before delivery to site. Use a suitably qualified coating inspector. And just based on that, I know the Hotdip Galvanizers Association has courses for this purpose. Assess the appearance of the item, take coating thickness readings, and according to SANS 121. And here you can see several pictures of well-designed, well-galvanized and fabricated items. These are nice big coping holes, allow the zinc to flow through when it goes into the zinc bath. At the end of the tubes, this gusset plate has been welded inside the tube so it can, the zinc can flow out. And the same on this one, with the holes are right in the penultimate corner of the item. Appropriate versus inappropriate. Again, you see this good fabrication, good welding. Same here with nice openings at the end. And here we have even a gate with the actual bolt, which is Hotdip galvanized, not corroding if it was only zinc electroplated, which is often what happens. And this is the less appropriate type of fabrication that we get coming into the galvanizing plant. What the guys don't realize, all the weld slag here and here, little holes, etc., and that hole not being in the right position can lead to very bad galvanizing, much the same as this. You can see these coping holes very small. You've got ash in the surface and this one as well. So why are vent, fill, and drain holes mandatory and their sizing and positioning most important? To immerse the item as quickly as possible in the molten zinc, to shorten the immersion time, ensure that no air pockets are formed. And here you can see a typical example where you've got an air pocket, which obviously needs to be repaired. To ensure no solidified zinc remains in the corners of the component. And here you can see taking out the zinc is solidified in that item. Above all else, to prevent explosions. Now, generally, if you have any moisture that's contained within an item that has been galvanized, as soon as it hits the bath, that moisture changes into superheated steam, which has got a volume change of 1 to 1700 times in volume. And this is basically what happens. It's extremely dangerous, not only to the galvanizer, where this can actually certainly maim or kill people. Selected components are excused from vent holes. Here we have an item like this, written galvanized on the inside, snorkels that allow the thing to be immersed, much the same as the heat exchangers. You can see the snorkels sticking out. And then when it's put into the galvanizing bath, it is forced in, so it actually displaces the zinc and it coats only on the outside, and then they cut the snorkels off afterwards. Duplex coating systems, as Robin talked about, painting or hot-dip galvanizing for color and enhanced corrosion control. Adding appropriate durable top coats to a correctly prepared hot-dip galvanized coating can increase its service life by up to 400%. Preparation is extremely important, including informing the galvanizer of intention to duplex, as the passivation stage must be excluded. Yeah, you can see some items that have been duplexed. This is a bridge which is hot-dip galvanized and painted in the V&A waterfront. There's a house which is about 80 tons of structural steel down in Royals. The steel was hot-dip galvanized, and then in factory conditions, applied 3 coats of paint, and then came to site. Items were put together and a final coat of paint was put on. It was given a 10-year guarantee. This is twist dry coal colliery, where galvanizing was painted with a substantial paint system. And this picture was taken after about 20-odd years, and there was nothing wrong with the coating whatsoever. Additional applications in mining, which is not happening in South Africa, but I just wanted to tell you a little bit about. Hot-dip galvanizing has been the coating of choice in deep level mining for more than 50 odd years. 23,000 tons of Hotdip galvanized shaft guides and buntons ready for installation in a 3-kilometer level deep mine. Here you can see the buntons standing on the surface, all ready to go into the mine. These are the spider web or steelwork. This is the vertical steelwork, which is shaft guides, all Hotdip galvanized for the life of about 25 years underground in the mine. Accurate assembly of the station steelwork, which happens quite frequently on the way down the mine at ground level before being transported down the shaft, is vital because each one of these components are now marked and taken down the shaft and assembled, and obviously you can't do changes down there. Then after 10 years of service, we often used to get involved underground, assess the components, and you can imagine what this looks like with 10 years of mining. There's a lot of junk on the things. We clean it off and measure the residual coating. And you can see here 256 odd microns. Thank you, Shannon.
Thank you so very much, Terry. We're going to now hear from Simon about some other applications where zinc is used.
Good afternoon, listeners. We have an enormous field to cover in the use of zinc in corrosion protection. We've given you a little taste of the essentials of galvanizing, both from Robin Clark at the Hotdip Galvanizers Association and Terry Smith, who's the technical expert on galvanizing and galvanized coatings, and the Duplex coating system where you put an organic coating over galvanizing. But there are other areas as well. Firstly, there is zinc, there's thermal spraying where you use molten zinc to spray onto a piece of equipment. If, for instance, you have steel that you feel can't be galvanized, you can use zinc thermal spray. If you can't galvanize it because we don't have a big enough kettle in South Africa to dip the component in, you would then zinc thermal spray. If you want something that's immediately available because it doesn't have to dry like an organic coating, then you would use a zinc thermal spray. I am hoping today that the chairman of the South African Thermal Spray Association, Mr. Adam Wintle, will actually be on and attending this webinar. And should there be anybody who's interested in having components thermally sprayed, please contact me at the International Zinc Association. We at the IZA are also interested in thermal spray as it's applied to marine applications, and we'd like to find a vessel where we could carry out a thermal spray of the vessel before we coat it, because we'd like to measure that over a period of time. The other issue concerns zinc-rich paints, often called cold galvanizing. There is a question about that, which Terry will then deal with later in the Q&A. There are two types of zinc-rich paint, what are known as organic zinc-rich paints and inorganic zinc-rich paints. And these particular materials have different applications. We are not able to deal with that in detail today, but the good news is that I am hoping that in September we will be having another webinar on continuous galvanizing, zinc thermal spray, and other applications of zinc. But that's for a later time. I would like to now show you a very fascinating film clip, which I think all engineers will find extremely useful. It shows you the application of zinc thermal spray on an item which could not be galvanized. It then shows you the use of zinc-rich paints, and then of a paint system where essentially you have what's called a duplex paint system. I hope you enjoy it and watch the text at the bottom. It's a very interesting presentation. Could we please show the film? Thank you very much, ladies and gentlemen. I hope you found that brief review of zinc thermal spraying very useful, and you noticed how organic coatings were used. The components were bigger than possibly the bars in the galvanizing plant. And if you have any further requests for information on zinc thermal spray, we would only be too glad to help you. Shannon, it's over to you now.
Thanks very much, Simon. We're going to now move to our Q&A, and we do have about 8 questions that have come through now. So I'll start at the top, and our first question is I'm not sure who this will be directed at. Perhaps Simon will be able to spread it over to the next person. But the question is, what is your opinion of the use of cold galvanizing products for local repairs to products which have been previously galvanized?
That's a Terry Smith, definitely a question for Terry Smith. Over to you, Terry.
Okay, can you hear me? I think Robin could also probably answer this. Years ago, we knew that the SANS 121 specification was coming out and would allow zinc-rich paints to be used. We did a number of tests at the association, and we found that a dual pack of a zinc-rich epoxy worked very well. That's now been packed into squish packs. There are 2 types on the market, very well done. And the reason for that is it's a great barrier, number 1. And number 2, the specification calls for, SANS 121 calls for a coating thickness of at least 100 microns. And this product will give it to you in a single application. So it's a very safe way of making sure that you get the right type of protection. The alternative is often used is the guys use sprays, which has come in aerosol cans, and the coating thickness that is achieved with that is about 10 to 15 microns, which doesn't necessarily do the job correctly.
Thank you, Terry. Another question we have is, what is your opinion on specifying bolt torque values if using Hotdip galvanized bolts? Because the understanding of the attendee is that Hotdip galvanized bolts should not be torqued with the torque range due to the coating causing artificially high torque measurements.
Robin, do you wish to answer that? Hello, Robin?
Yeah, I think I was muted for a while there. My apologies. Tests show that on initial slip between zinc surfaces, the coefficient of friction is temporarily high because there's an element of spalling that takes place. But after that, the coefficient of friction is similar or lower than a steel-on-steel friction.
Robin, we
so generally, if the nuts are lubricated.
Robin, we're losing you.
Yes, I'm just checking to see what the issue is. Am I back again?
Yeah, you're back.
Okay. So with sufficient lubrication, there shouldn't be a problem. I don't know what Terry's view is.
Terry, would you like to comment on that?
I can do that. I know that over the years that I've been involved in this industry, around about 30 odd years, we've always used the turn of the nut method to achieve fixity on a Hotdip galvanized bolt. But I understand that CDC have done some tests where they have used torquing, and there are some new methods available, and I'm sure that can be supplied to the person that's asked this question. I see it's Craig Knowles. I'm sure
CDC refers to a company that manufactures bolts in the Johannesburg, South Africa area, and Terry Smith or myself, we can supply with details to Craig Knowles. The next question concerns, would it be possible to give information on how to get the design chart? Robin, that's over to you. Do you have design charts available?
We do have design charts available. Our website obviously gives access to the details to Chantal, who will be able to assist anybody inquiring.
So Carolina, we'll give you the contacts for the Hotdip galvanizers, or go to their website. Over to you, Shannon.
Thanks very much for your answers so far. I've got another one now for Terry Smith. In terms of the lifetime of the coating, how effective is the galvanizing spray used subsequent to welding repairs?
Zinc metal spray is an excellent way of doing repairs. However, there are a number of things that one has to take into consideration. Number one, it's not a metallurgical reaction, it's a mechanical action. So the surface has to be absolutely roughened. When you zinc metal spraying, you have to coat the coating thickness should be substantially more than a general galvanized coating at that particular area. And afterwards, because of roughening where the zinc metal spray attaches itself, the area can be wire brushed with a stainless steel wire brush to remove the excess zinc. Just remember that it is also application dependent. So when you're using a big structure and you're zinc metal spraying, you have to rely on applicators that know what they're doing, because if they don't, whereas Hotdip galvanizing is a metallurgical reaction and the galvanizer has very little control over that reaction when it happens.
Thanks, Terry. We've got a question here. Can any of the speakers give their opinion on the detrimental effects of Hotdip galvanizing grade 10.9 bolts with specific regard to hydrogen embrittlement? Can you trust such bolts or reject them outright? I think that will be for Robin.
Yeah. Hi. Am I in play?
Yes, we can hear you.
Okay, super. Sorry, I'm just having some technical difficulties over here. My apologies. The topic of hydrogen embrittlement in high tensile bolts is an interesting one, and it's the one that is undergoing continuous study. What I can tell you is that in Germany in particular, it's done on a consistent basis at high volumes with known issues. And the slight change in process that our colleagues in Germany underwent is that instead of a pickling through an acid process, what they do is they use a mechanical cleaning to take any oxides off prior to Hotdip galvanizing. They then flash pickle, literally for seconds, to take the remaining oxides off. And to date, there hasn't been issues. During the evolution of the issues associated with hydrogen embrittlement, there were attempts at limiting pickling through inhibitors and so on, but controls at points in time may not have been what they should have been, and certainly there have been case studies with hydrogen embrittlements of high tensile bolts. There's also been questions and research papers written on what role stress relieving might play prior to the bolts being galvanized to rid the parent material of any residual hydrogen. So we believe it can be done, but we believe it needs to be done, as I say, through a mechanical process with flash pickling. And we are in talks coincidentally with people like CBC on whether we should be maintaining our position as it stands at the moment. I know that the Red Book by the South African Institute of Steel Construction doesn't advocate the use of high tensile fasteners, Hotdip galvanized, and it's the subject of discussions at this point in time with them.
Thanks very much, Robin. Simon, is there anything you'd like to say, or Terry?
I would love to say something to that. Robin is 100% correct. The thoughts that have been talked about in the past was, instead of using 10.9s, which are, as Robin said, unless they imported, they have some issues in this country because they don't galvanize them correctly. Rather to use grade 8.8s and a bigger size at the same thing, and because grade 8.8s can be galvanized without issues, that's a far safer route to follow.
Thank you, Terry. Simon, have you got anything to add?
I was just going to say that if you look in your copy, we have hard copies of Essentials of Galvanizing. There's an article here entitled Placing Hydrogen Embrittlement of Fasteners in Perspective. So this contains further information should you so require it. Thanks very much.
That's great. And just a reminder that everybody attending the webinar will receive an e-copy of that booklet. So you'll be receiving that after the webinar, or it has already been sent as far as oh no, afterwards. So we have another question for either Terry or Simon. Lance Stephen is asking your opinion of Hotdip galvanizing on steel for immersed conditions, i.e. subsea or offshore. Same question for the use of zinc-rich primers.
Over to you, Terry.
I know that Hotdip galvanizing has been used in sea conditions, but the major problem of the galvanized coating is at the worst condition, which is at the high level or the tidal zone, which is extremely aggressive for most materials and coatings. I would say that if Hotdip galvanizing is used in sea conditions, continuously immersed, they should be supplemented with some anodes, which will give you additional protection for the life of that item.
Thanks, Terry. Simon, have you got anything to add there, or shall we move on?
No, you can move on. Thank you very much, Terry. Thank you.
I have a question. Well, it's more of a statement here from Lina Hockaday. I think what we'll do is I'll get this information through to you after our webinar. She just says that she is interested in visiting. Oh, it seems to have disappeared, but we will definitely get back to you on that. Somebody else has got a question here. Can galvanizing be used for petrol tanks?
Terry, can you comment? I'm not sure if they mean internally or externally.
Well, externally, it's not a problem whatsoever. Why would one want to galvanize internally? Maybe Robin can comment about that. Certainly very difficult to galvanize inside a petrol tank, because the zinc has got to flow in and flow out, and the air pockets that we create would be a problem.
Robin, over to you.
I wouldn't predict any I wouldn't predict any known adverse sort of circumstances. As with any liquid tank, we would want the surfaces to have developed the full zinc patina before we filled it up with any liquids, really. And I can't think of any circumstances. I can't even think of any examples, truth be told, where that's been done before. Interesting question. I'd like to reply to that person after applying my mind on a case relative to some case studies. But offhand, I can't see any reason why not. Let me just apply my mind, and I'll give a written response via yourself, via the IZA to the delegate.
Thanks very much, Robin. I'll be sure to pass your details or their details on to you to answer that. The next question is, why is it that zinc coating grams per square meter used for interior products is 30, minus 50 grams, I think I'm reading this correctly, whereas in Europe, USA, and SA all spec 100 grams, but it is accepted that throughout the world in an interior air-conditioned environment is even 30 grams lifespan is 100 years.
Shannon, I'm not quite sure what the question is. The person who's asked the question is getting at. But Terry, can you guess what, or Robin, what they're getting at here?
I can answer, add something to that. I know that the Institute of Steel Construction have a division where they have light steel frame buildings which are made from continuous galvanized sheeting. They are using a Z200, which is probably around about 12 microns in coating thickness. And because they are interior and very dry, they have predictions of about 100 years of life. So the biggest problem with that is that if the building envelope breaks down, obviously you have extreme corrosion on these very thin coatings. I don't know if that answers you, but South Africa and Europe generally have the same specifications. The SAN specifications are a derivative of ISO standards and very similar to the ASTM specifications as well.
Shannon, I just think we should deal with the last question, which is, can you please comment on double dipping of components? I think both Terry and Robin will comment on that.
Yeah, double dipping obviously can happen. Bear in mind that there are some huge kettles around, some of the kettles up to 4 meters deep. So double dipping works that you can actually dip an item. The problem is that the galvanizer will probably charge you twice the cost because the item is not coming through the galvanizing bath very quickly. You can double dip long items. In fact, we galvanized 22-meter crane beams in a 40-meter kettle by double dipping, but the cost is prohibitive. So if possible, one should look at the possibility of modular size, which has been like we did with the Athlone Stadium. I don't know if Robin would like to add something to that.
That's pretty much spot on, Terry. I would agree with that. People ask the question, what is meant by double dipping? Double dipping obviously isn't a process where after having galvanized, we have another go at it to change the coating in any way. The understanding of double dipping is when you have let's say an article of 10 meters and you only have a 5-meter kettle available, can you successfully do both ends, okay, in 2 separate dips? And the answer is categorically yes, with the appropriate care to attention. And it happens quite frequently, but as Terry quite rightly says, at some level of premium, because there is a utilization factor which the galvanizer will need to cost into doing it that way.
May I just add something that I just thought of? What's important is if you have a double dip item like a crane beam, bear in mind that there is the aspect of distortion when one part of the crane beam is into ambient temperature and the other half is in the galvanizing kettle at 450 degrees C. So one would employ an expert galvanizer that understands this because usually the flange thickness is about 25 to 30 millimeters and the web is only about 10. And there's different cooling rates at these steels. So bear that in mind.
Thanks very much, Terry.
Simon, if I could, sorry, Shannon. No, Terry's 100% correct. So what would happen under those conditions is that the thermal gradient would be dealt with by making sure that the areas are covered with thermal blankets and other methods like that to control the cooling and mitigate the risk of distortion. And as he says, there are a number of pretty good galvanizers well versed in that and are able to minimize the risk of distortion for double-dipped articles. Thank you. Sorry about the interruption.
No problem at all. Simon, is there anything you'd like to add before I wrap things up?
No, I'd just like to thank Robin Clark from the Hotdip Galvanizers Association, Terry Smith, John Matthews from the Master Builders of South Africa. Thank you for your contributions. Thank you to all those who've participated. Please contact us should you need us to come out and do any sort of inspection or investigation for you. We will hopefully be having our continuous galvanizing seminar later in September, but Creamer Media will let you know. And thank you to all for Creamer Media for putting this all together. Thank you very much.
Thank you very much. I'd also like to thank all our panelists for joining us today, as well as all our attendees, and to everyone who participated in our live Q&A. If you haven't had a chance to ask your questions or we didn't get a chance to answer you, we'll happily connect with you after the webinar. And we do have your question and we will send all the details to our panelists. I thank you very much for joining us today. Don't forget, to get your copy of the Essentials of Galvanizing, you can email Renette at engineeringnews.co.za, or we will send it to you directly. Stay safe and stay well. Thank you so much for joining us. Goodbye.
Goodbye. Goodbye.
Thank you, Shannon.